Hey guys, as promised, these are the video lectures for the rest of the chapters in the book that we're going to go over this semester. And so this is chapter 6, which is project planning, project time planning, and networks. Okay. So what we're going to talk about a little bit is on activity on node versus activity on arrow. This is basically just more ways of showing schedules and being more specific and more, right? We talked about it in chapter 5, the Gantt chart, but now this kind of shows you all of it in more detail. And so we're going to talk about dependency relationships, right? We talked about that a little bit already. Critical path, the resource constraints, and with time constraints, right? So all of these are just a little bit more advanced techniques in the Gantt chart world. Network methods are more sophisticated planning tools than the Gantt charts are. A Gantt chart should be drawn after a network has been developed. So the network is kind of the details, and the Gantt chart, remember, is more of the top level stuff. And so the two methods are activity on node or activity on arrow, right? Really the difference is this one it's a node based, right? And this one is that there's arrows and the activity is on the arrow. It's not really rocket science. So it's no big deal. So the activity on node, we call it AON. It's easy schedule activity in project is basically present each schedule activity in the project is represented by a node or a block, right? So the activity is inside the block, and then it links to another block which has another activity, and so on and so on. So the project is represented by a network of nodes connected with arrows arranged in sequence as specified by immediate predecessors, right? I do this one a lot. That's kind of the way I go. So you can see an example. There's the different activities and their predecessors. You can see, right, because E can't be performed until C and D are finished. So C and D kind of have a parallel, and then E and F, right? It's no big deal. I actually put it where usually there's an activity and there's an output. And so I put the output right here, and then the next activity goes here, which needs this as an input. Right? That's what I do. In large projects, good practice is that AON networks have only one start and one end node. If the project does not have a single end node or a single start node, then you insert a dummy activity into it to make it happen, to make it end, right? So if you look at this example, if this was just kind of the flow, right? Well, there's not really a start button because there's two things. So you insert the dummy variable start, right, and insert the dummy variable end. So then it's over. So, because the really big ones, the good projects have one that starts them and one that basically ends them. And so that's your start and end points if you want to look at it that way. On the arrow one, basically each activity is represented by an arrow with nodes at each end to represent the start and finish of the activity, right? So you've got the start point and the end point, and then the activity sets on the arrow. It's just a different form of it. They're more similar to Gantt charts than the networks are, AON networks, but they necessitate the use of dummy activities as well, right? So basically you can look at the AON diagram and convert it to an AOA. And so you can see there the dummy activities, basically now you've got the start time, right? Then there's the buying the computer, developing the logic of the program, pay for the computer, but you've also got this odd arrow down because that one also has to link to that one, right? So all of that has to happen with this one. The dummy activities are basically used to show predecessor relationships. They're called dummies because they are not real activities and involve no work, right? So you can look back here at kind of where the dummy is here because there's not really, it's just an arrow from buy computer to install program on the software, right? Program on the computer. So you need this dummy to be able to get from there to there. So it's just kind of a weird way to look at it. Both AON and AOA kinds of networks are used in industry, but the activity on node is way more popular. So you'll use it from now on. You'll end up using it a great deal. So you can see the AON network, right? And so you can see getting dressed, right? So you start with wake up and you keep on going through, and you can see down here the duration in seconds that it takes you to get up. So it takes about a minute to get them dressed. It takes 10 minutes to take a shower, right? And you can see all the way through. It only takes you 40 seconds to put on your underwear, which is amazing to me. But that's the kind of thing that you do. So there's types of dependencies, right? There's the mandatory ones that basically it's impossible to reverse the sequence. There's discretionary that basically can delete the dependency to fast track the project if you could. And there's external, which are dependent on some event external to the project, right? Those are all dependencies. So you can see here, you can get rid of some of these and you don't have to worry about it, right? Because there's some that are mandatory and some that are discretionary. This one is pretty discretionary. Dry, brush your hair, right? You can get rid of it if you had to. If you're pushed for time, you can get rid of some of these things, right? You can get rid of the socks because they don't really have a place if you don't need them. You can even get rid of the shirt and the tie, right? So if you had to really, really rush it, you could just put on underwear, put on pants, put on shoes, and go on with life, right? So, because that's the ones that are really dependent on each other. So you look at different activities, right? From the preceding activities, you had 61, you were starting at 61, you finished at 660, you got the shower at 600 seconds, right? So basically you need to think about the end date is basically the start date plus the duration minus 1, right? That's how all this works. So if you want to calculate what the end date is, you take the start date, add the duration, and then minus 1 is where you're going to end up, okay? So that's how that works. So why the minus 1? Well, you consider a 5-day activity starting on Monday, the first of the month, right? And so day 1, you start it on Monday. On Friday, the 5th day, you finish it, right? So the duration was 5 days. That makes sense. So the end date plus the start date, the start equals the start date plus duration minus 1. And so you can look at it that the assumption is that the activity starts Monday morning early and finishes late Friday afternoon, right? So if you do the math, you end up having to take the 1 off because of the way it works. Earliest time for activities, basically the forward pass, is the calculation of the earliest start date and the earliest finish dates for the uncompleted portions of all the networked activities, according to the Project Management Book of Knowledge, right? So you can look at just the forward pass. You can see the different things here, and it's basically the early start, the early finish, and the duration. You know, if you can get all those to line up correctly, that's the kind of thing you're looking for, right? So the finish date, remember, is the start date plus the duration minus 1. And so you can look at it when an activity has more than one predecessor, like activity C, you can use the latest predecessor to determine the earliest start date, right? So the latest one is going to give us the best, is going to give us the earliest start date that we can do. And so if you look at it, wait a minute, I can't remember the finish, the duration, right? So the latest one is really D, if we look at it from that perspective. So the backward pass is basically the calculation of the late finish dates and the late start dates for the uncompleted portion of the schedule. It's determined by working backwards through the schedule network logic from the project's end date. And so the end date may be calculated in the forward pass or determined by the customer or sponsor, right? So early finish equals early start plus duration minus 1. Late start equals late finish minus duration plus 1, okay? These again, I don't really care if you remember all this stuff in this, because this is a lot of details about scheduling that's like, you know, I mean, if you are a project analyst, a program analyst in industry, this is something you really need to worry about. But for me, it's kind of like, okay, we check the box. I'm going with live. So you can look at the early start, early finish, late finish, and you can get all of those on this with the activity and the duration, and you can figure out all the different parameters that you would need to, okay? The critical path is basically the longest path through a network from start to finish. The activities on the critical path are called the critical activities because they have to happen or the thing can't finish. You can't finish the project and finish the task, right? So why is critical path such an important concept? It determines the project's duration, which is always important, and it shows the project manager where to focus his or her attention, right? And so the critical activities have the least flexibility because they're the longest things. No matter what's happening, those long items are going to be the ones that have to be worried about. The critical path will generally change from time to time as activities are completed ahead or fall behind schedule, right? And this will happen. It's not very stable. It can change without a moment's notice. And it does it without warning. And so you do not know where to focus sometimes because you got to watch it. Because some projects a task is planned to be so long, but then they change. And when that changes, then the critical path changes and you have to start watching something else. These are also called the long lead items in development. So there's also slack, right? And so slack can equal late start minus early start and late finish minus early finish. And so then total slack is basically the total float or simply the float of it, right? And so that's what we're after. Slack represents scheduling flexibility because now you can look at that as well. And so how much later than early start time is permissible, basically how much an activity can exceed the expected duration is also what slack does. And some activities cannot be delayed by any amount, so there's zero slack in it, no matter what you do. And this is often the case with the critical path because the path is automatically the longest part, and so you can't move in any direction. So you can look at this. Is there any kind of floating on it? And yes, there is. In this case, there is float on the critical path. And so you can see, let me see which one is it. The duration. And so you can see here there is some, I'm like brain dead right now, but there is some on the critical path. So why should the Gantt chart be drawn only after the network has been developed? And basically it's for the fact that for each activity with float, a decision has to be made whether the activity should be performed as soon as possible or only later, right? And we actually showed that last time with the one that can move. You didn't really care, but in the beginning we just put everything on the one side. Free slack is basically total slack is late times minus early times. Late times minus early time. And its amount is the amount of time an activity can be delayed without delaying the project. Free slack is basically the amount of time an activity can be delayed without delaying at least another activity, right? If an activity is delayed more than the free slack, it will basically delay the successors that are scheduled as early as possible, and that could be disruptive to the project. So, is there free slack in this activity? Right? You can see the critical path right here, and if I think about it for a minute, I believe there is free slack because you can move any of these, right? Because these take 10 increments is the duration. So these could move because these are all up for grabs here. They can move wherever you need them to because the critical path is up there on the top, right? And so basically you can look at it from this way as well because you can see the free slack, free float of activity X basically is 2 days. You can see it here, right? If delayed for more than 2 days from its early start, X will delay the early start of a successor. The float of activity X is 12 days. After that, it will delay the project, right? Because it can float all the way out through here, really. Yes. So you can see how they can play together in all this. So it's kind of weird to see this stuff. But again, this is common sense, If you have this time, you can float things, you can move them around and that kind of thing. So the summary of the planning process, you need to list the stakeholders, right? Determine the project scope with the stakeholders, develop the WBS, draw the table. I don't know what that one means. Draw a table. What that mean? Draw the network diagram. Do forward and backward paths to determine the critical path in the slack, and decisions regarding early and start date activities. Basically, you have to decide these things, and then draw the Gantt chart, right? So scheduling with resource constraints. Basically, this project could theoretically be done within 4 days, right? Because it takes 1 day for A, 2 takes C, so that's the longest one, and 1 day for the end, right? So all that works out. But basically, if activity B and activity C have to be done by the same resource, the project takes longer, right? So if B and C both have the same resource, that's really 3 days instead of 2 days. So we got to figure out what to do about that. So that's what resource planning is all about. And so you can look at basically trying to figure out how to, if you just did it graphically, right, and you looked at all the projects you had or all the tasks you had to do and the resources required for it, you can see how crazy it goes. You know, for the first 10 increments, you need 5 workers. For the next, few, you need this, and so you've got this, hills and valleys, which are crazy when you look at it. So what you can do is spread it out, right? Smooth the worker loading, and you can figure it out a lot easier. So you can give them not as many people doing things. So if you move things around, and with floating you can do that, then you can get the resources allocated appropriately, right? Because if you look at this, you're going from 5 people, I don't think there's anything, well then there's a spot here, there's nobody, up to 23 people, and then it falls back out, and so it's nuts to try to put all these people together. Versus here, you look at it, you're averaging, 14, 15, 13 people right there, right? And that's a lot easier to manage in the end. So workload, you need a company-wide system to manage workload on all projects concurrently because people have different things they're doing, right? And basically, why should smaller projects be loaded onto the system as well? Because they also contribute to the workload, right? Because then you can use people and send them back and you don't have to pay for them all the time. Because if you had to sit here and pay for 23 people throughout the 50 weeks of this project, that's a lot of waste, right? Instead, if you paid for even 15 people for 50 weeks, that's a lot better than the 23, but that's a lot of money. It's just because you changed the resources. And even in here, you might be able to then send them off and do small projects and get them back in the system, right? And so you're effectively using your resources when you do that. Okay? Hopefully, this was the last chart on this one. So hopefully chapter 6. Again, this one is to me kind of a chapter because we talked about the Gantt chart, and that's the really big deal for me. I'm not really that big into scheduling, and doing a lot of detail on these things. So that's the end of that one. Again, if you have any questions about this, see me during our class time when we're talking about projects, or you can also talk to me or send me an email, or we can chat and that kind of thing offline. So hopefully this works for you. Talk to you later. Bye.